Good morning, grade 8 learners. Welcome again for this week's new learning episode. I am teacher Geraldine Pilas Prilia, a grade 8 mathematics teacher, your teacher for this week's video lesson. Are you ready? Prepare now yourselves for we are about to start our lesson. For this week's video lesson, we will be discussing about axiomatic structure. For our objective, you are expected to illustrate the need for an axiomatic structure. In our last video, we defined axiom or postulate as a mathematical statement that is accepted to be true without any proof. So these are useful in proving theorems and other statements in geometry. Now let us discuss reflexive property. Reflexive property states that a number, a figure, or an object is always equal or congruent to itself. For the reflexive property of equality, if A is a number, then A equals A. For the reflexive property of congruence, if line segment AB is a line segment, then line segment AB is congruent to line segment AB. Now, let us proceed on symmetric property. First is the symmetric property of equality. So, symmetric property of equality states that if one value is equal to another value, then the second value is also equal to the first value. So, if we have A equals B, then B equals A. For example, if x plus y equals 7, then we can say that 7 is equal to x plus y. Now, for the symmetric property of congruence, it states that if a figure, let's say figure A, is congruent to another figure, which is figure B, then figure B is also congruent to figure A. So, for example, if line segment AB is congruent to line segment CD, then we can say that line segment CD is also congruent to line segment AB. Next is we have the transitive property. For the transitive property, we have transitive property of equality and transitive property of congruence. For the transitive property of equality, it simply states that if we have two numbers that are equal to each other and the second number is equal to the third number, then the first number is also equal to the third number. So we have here, if A equals B and B equals C, then we can say that A equals C. That is according on the transitive property of equality. Next is the transitive property of congruence. So if figure A is congruent to another figure, which is figure B, and figure B is also congruent to another figure, which is figure C, then figure A is also congruent to figure C. Now we have here an example. If angle A is congruent to angle B, and angle B is congruent to angle C, then we can say that angle A is congruent to angle C. Now let us proceed on the addition property of equality. So if two expressions are equal to each other and you add the same value to both sides of the equation, then the equation will remain equal. We have here, if A equals B, then A plus C equals B plus C. Or, if A equals B and C equals D, then A plus C is equal to B plus D. For example, we have the equation x minus 3 equals 7. So using addition property of equality by adding 3 on both sides of the equation, we will have x minus 3 plus 3 equals 7 plus 3. And that will result to x is equal to 10. Now let us proceed on subtraction property of equality. So this property tells us that if we subtract from one side of an equation, we must also subtract from the other side of the equation to keep the equation the same. So we have here, if A equals B, then A minus C equals B minus C. Or, if A equals B and C equals D, then A minus C is equal to B minus D. For example, we have the equation x plus 2 equals 11. So using subtraction property of equality by subtracting 2 on both sides of equation, we have x plus 2 minus 2 equals 11 minus 2. So we will have x is equal to 9. Next is the multiplication property of equality. So this property states that when we multiply both sides of an equation by the same number, then the two sides of the equation remain equal. So if A equals B, then A times C equals B times C. Or if A equals B and C equals D, then A times C is equal to B times D. For example, we have the equation x over 4 is equal to 5. Using multiplication property of equality, we multiply 4 on both sides of an equation. So we will have x over 4 times 4 is equal to 5 times 4. So we will now have x is equal to 20. Next is the division property of equality. So this property states that when we divide both sides of an equation by the same non-zero number, the two sides of equation remain equal. So if we have A equals B and C is not equal to 0, then A over C is equal to B over C. For example, we have the equation 8x is equal to 16. So using division property of equality, we divide 8 on both sides of the equation. We will have 8x divided by 8 is equal to 16 divided by 8. So we will have here x is equal to 2. Now let us proceed on substitution property of equality. So this property states that if A equals B, then A can be substituted for B in any equation and B can be substituted for A in any equation. So if we have A equals B, then A may be replaced by B in any equation. Now we have here the first example. Let A equals B. Now we have the equation A plus 5 equals 7. Substituting A for B, we will have B plus 5 equals 7. Another example for the substitution property of equality, we let x equals 5. So we have here the monomial 5x. Now, substituting x to 5, we will have 5 times 5 equals 25. So that's all for this week's lesson. I hope you have learned a lot from this. For your assessment, please refer to your LAS for this week and answer all the questions asked. Thank you for listening, everyone, and God bless us all.